Good morning, my YouTube viewers. In this particular video, what we're going to talk about is the chi-square distribution. So the chi-square distribution is used in test of independence and goodness of fit test. It describes the distribution of the sum of squared standard normal variables. It is also used in the analysis of variance, or ANOVA, in estimating population variances. So what I've done is I've actually created a chi-square distribution for you to see. So you've got x is x is going to be a value of 1 to, let's see how far we go, 1 to 30 in half a unit increments. And then what we're going to do is we're going to create the chi-square distribution for each value. So for cell A2 equals chi-square dot dist brackets A2 comma C2 comma false. And so C2 is your degree of freedom, and A2 is your distribution. And so if you change the degree of freedom, then it's going to change the shape of the distribution. And so what I did was I put a slider in there. And then so if you put a slider in there, so now we've got a degree of freedom of 11, and so you can see that that changes the shape of your distribution. So you can see as you change your degrees of freedom, you change your distribution shape. And I put a slider in there to show that to you. So now we have 0 degrees of freedom, so that's incorrect. And now we have 4 degrees of freedom. And then that's changed your shape of the distribution. And you can have as many degrees of freedom that I set up. I'm not sure exactly how many degrees of freedom I set up, but at the moment we've got 20 degrees of freedom. So every degree of freedom is going to give you a different distribution. And so that is the shape, your chi-square distribution. And one thing about the formula is false means it's a PDF. That's a probability distribution function. And if it's true, it's going to be, I think, a CDF, but we use cumulative distribution function. So, but we want to have a PDF, which is a probability distribution function. So that just gives you an idea of what the chi-square distribution looks like. So this completes our video. The next video is we're going to be discussing the t-distribution, and I hope that you decide to watch it.